All right, so if I look at this question, this is 8 square root of 5 plus 9 square root of 20. Before I start this, I want to make sure we talk about what this means again. This means this is 8 times the square root of 5 and 9 times the square root of 20. Now, you'll see that right now what's underneath the radical, the 5 and the 20, are not like terms. But I have a way to make them like terms. And the way I'm going to go ahead and make them like terms is to simplify that 20. So I'm going to go through and rewrite this. This is 8 square root of 5, nothing changes there, plus 9. I don't want to write that the square root of 20 anymore because I know my perfect squares. The first one I have is the square root of 4 is equal to 2. The square root of 9 is equal to 3. The square root of 16 is equal to 4. And so on. That list we've talked about before. So I want to break that 20 down into 4 times 5. Now I can't use any two numbers. One of the mistakes that I see is you would rewrite that 20 into 2 times 10. Now that's not wrong, but it doesn't help us with anything, right? Because right now I can't take anything out. There's nothing I can do with that. So the only numbers that you want to rewrite this as has to be one of those numbers over here in your perfect square list. So the square root of 4 comes out and is 2. And you have to multiply that 2 times 9. So now what this leaves me with is 8 square root of 5 plus 18 square root of 5. Now because of that, now I have what's underneath the radical are like terms. So I can go ahead and add the 8 plus 18. And that just gives us 26 square root of 5 is negative 7 square root of 2 plus 9 square root of 50. So the first thing you want to do is rewrite that. And that 50 becomes 25 times 2. And again, I only use numbers that are that perfect square list. The square root of 25 is 5. It comes out, I multiply that times 9. Now I'm left with negative 7 square root of 2 plus 45 square root of 2. Because these are now like terms, I go ahead and add them together. So that becomes 45 minus 7, which is 38 square root of 2. So when you are multiplying radicals, if I have a times the square root of 3 times 2b, it's terrible looking too, times 2b square root of 3. No, let's use 5. So with this, I can make this joke. Anything outside, you multiply together first. And that would just give you 2ab. Then multiply the inside together. And that gives you the square root of 15. And that's all you can do with your answer. But they do get more complicated than that. So if I look at, on the worksheet, 2b, because after you multiply, sometimes you'll have to simplify, and this is a perfect example of this. So what I have here is I have no outside portion, so I don't have to multiply those. But when I multiply the inside of that, 5 times 5 gives me 25. And then x times x gives me x squared. And then as soon as I see I have a variable underneath that radical, I look back at the directions, and then I see this lovely note that says variables are positive real numbers. And that's really lovely, because if I don't say that, then you have to worry about the absolute value, but we don't. So the square root of 25 just comes out and is equal to 5. And then the square root of x squared is just equal to x. So after you multiply, you will have to simplify all of the radicals. So 2 times 18 is just 36. Then I have x times x to the 4th, which gives me x to the 5th power. And then for the y's, this is y to the 1st and y to the 1st. So when I add those two together, that gives me y squared. Now to simplify that, the square root of 36 comes out as a 6. This is the part where you have to watch what's going on here. This is understood to be to the index 2. So 2 divides evenly into the exponent of 5. How many times? Well, 2 goes into 5 evenly twice, with a remainder of 1. So what that means is anything that comes outside or divides evenly, that means I have x squared that comes outside. My remainder was too tiny of a 1. My remainder is equal to 1, so that means x to the 1st power remains inside the radical. If it goes evenly, it comes outside the radical. And if it is a remainder, it remains inside the radical. I do the same thing with y squared. Most of you might not need to do this, but 2 goes into 2 evenly one time. So that does tell me that y with an exponent of 1 comes out and there's no remainder. So that would be your final answer with that question. So this is 2D, and it's the square root of 6 times the square root of 3 plus the square root of 2. So I think one of the most powerful things that we can ever do in math is to think about this as a simpler question. So if you had a 6 on the outside, and just make something up. This is kind of a chance for you to think about the rules. That's all I care about. You're just making this up. What if it was 6 times 3 plus x? What would you do? You would distribute that, right? Well, because of that, and this idea of what I'm doing over here, this is just to help us, okay, what are my rules? Because math is one of those things that whatever the rule is, it will always be the case. So that's what I'm going to do here. I'm going to take 6 and multiply it times 3. And then I'm going to take 6 and multiply it times 2. And the reason I can multiply those numbers, again, all of this are all underneath the radical. So I go ahead and do that. 6 times the square root of 3 and 6 times the square root of 2, which will give me the square root of 18 plus the square root of 12. Now, this is not like terms. So you cannot add them together, but you do need to simplify. So I go back to that list of what can divide into 9. And remember, what is the list that we're checking for? We are checking 4, 9, 16, 25, 36 are perfect squares. not any number. I wouldn't want to break it down into 6 times 3 again. So 18 is the same thing as saying 9 times 2. And 12 is the same thing as saying 4 times 3. So I know the square root of 9 is 3. That comes out of the radical. The square root of 4 is 2, so that comes out of the radical. And I'm left with 3 square root of 2 plus 2 square root of 3. And you cannot do anything with this, so that would be your final answer. If you guessed that you're going to have to go through and FOIL this, you are absolutely correct. Go through and multiply this. 7 times the square root of 7. Both of those are underneath the radical. Both of those 7s are underneath the radical. So that just becomes the square root of 49. Now the next one is going to be 7 times the square root, 7 times negative 3. This 7 is underneath the radical. This 3 is not. So you just go ahead and write that as minus 3 square root of 7. Finish that. So now it's going to be 3 times the square root of 7. So that is going to be a positive 3 square root of 7. And then I'm going to go ahead and take and multiply 3 times negative 3, which gives me a negative 9. Now if you notice, these two cancel out because one of them is negative and one of them is positive, so they completely go away. And then the last thing is the square root of 49 is 7. So this just becomes 7 minus 9, or negative 2. Because the idea that that cancels out because one of these terms is positive and one of these terms is negative, we're going to be using when we talk about division.